The Sierra Nevada is one of the most mystic mountain ranges in the United States. It has 3 national parks: Sequoia, Yosemite, and Kings Canyon. It holds a variety of information in the development of its landscape and rock structure, even outside the national parks themselves. The rocks we see today did not originate from the Sierra Nevada, but from the ocean. The rocks that became a part in the Sierra Nevada were originally formed in a deep oceanic setting between 150 to 600 million years ago. These rocks were created in a variety of different settings that involved sedimentary and igneous processes. The subduction process helped bring these rocks together and were later metamorphosized to a certain stage. Today, these rocks are known as the metamorphic rocks of the Sierra Nevada. Signs of these rocks can be seen in Kings Canyon, which include the Kings Ophiolite and Boyden Cave. Granite formed later on between 150 to 85 million years ago. These rocks are known as the plumbing system of the Sierra Nevada because of a major series of past volcanoes that were similar to the modern Andes. As the volcanoes erupted at the surface, granites crystallized from magma below the crusted surface. Over time, the volcanoes became extinct and eroded away. The volcano underpinnings remain as the granites. Later on in time, uplift began to occur. Some areas that were lower in elevation started to rise up. Geologists still debate today on how much uplift had helped make the elevations what they are currently. There were 2 key carving tools that helped sculpt the Sierra Nevada. The first one was stream erosion. Running water carried rocks and other debris downstream and helped carve out the canyons. Kings Canyon has one of the deepest canyons in the United States due to stream erosion. Later on, glacial erosion finished off the carving process when moving ice picked up rock and other debris. It gave some of the valleys their U-shaped profiles. Glaciers were spread out through the Sierras, especially through areas of Kings Canyon. These processes helped expose the granite and alter the landscape. Many geologists have recorded information from its rock structure that dates back millions of years. The Sierra Nevada houses many types of rocks like granite, serpentinite, and many others. The video you are about to see takes us on a trip through Kings Canyon National Park. This park holds a visual perspective on the demonstration of stream erosion. If you're starting your road trip for Fresno State, follow 168 till the end and then go east onto SR 180 eastbound. Follow 180 eastbound to Clovis Avenue. However, in the future, this may change once the eastern 180 extension is opened. Make a right onto southbound Clovis Avenue and immediately get into the left turn lane. Head eastbound onto Belmont Avenue. Follow Belmont Avenue eastward toward Pine Flat Reservoir. As you continue east toward Pine Flat Reservoir, the road will eventually end up paralleling the Kings River with the river on your right. This is located 12.2 miles from the Belmont and Academy location. Park on the right at the intersection with Piedra Road. At this location, this area used to be a part of the Oceanic crust. We see rocks that are part of the Mantle section in the Kings Ophiolite. These are one of the many older rocks in the Sierra Nevada. These rocks here are over 480 million years old. These rocks are composed of serpentinite, which is part of the mantle beneath the oceanic crust. Serpentinite forms from peridotites by hydration of the original mineral rocks. Olivine is the most common mineral that gets hydrated. These rocks were variably serpentinized because some were converted partly. From our first stop, turn right onto South Piedra Road and cross the bridge. The next stop will be 0.3 miles from stop 1. Turn right into Winton Park and park immediately on the right where the first parking slot is available. Our next stop is an abandoned rock quarry, which has rocks that are part of the original Mantle section. This area represents solid state flow fabric in their original peridotites. Before rocks become serpentinite, they need to have exceedingly high temperatures for minerals to deform by plastic flow. This was not molten material, but was a solid state flow of mantle material. When geologists look at ophiolites, they get a snapshot of the processes that occurred deep in the earth. This section is an example of the mantle fabric with a form of layering. This is the frozen record of the flow of the mantle. This area has more oceanic mantle and gives us a better 3D glimpse of peridotite. The rock quarry houses many types of peridotite, which include dunites and hasbergites. We see these types of peridotite in the oceanic crustal material called gabbro. This gabbro rock shows us that it was being formed at a lower temperature than the solid state flow fabric. This shows an example of the serious metamorphism this gabbro went through after partial melting of the peridotite occurred. This would have cooled first, recrystallized before the stretching occurred, and then heated up again at a solid state to cause the stretching itself. Some of these igneous rocks have recrystallized to a form of metamorphic rock. You may not see continuous layering, instead you may see blobs of things that are encased within the rock. The gabbro we found was a big chunk of rock to us, but the surrounding rocks were made more of peridotite. From stop 2, turn around and leave the park and turn right onto Piedra Road. Proceed a short distance, which is like a few tenths of a mile on Piedra Road, then turn left on Elwood Road, which is also signed to Wonder Valley. Follow Elwood Road for some distance at the intersection of 180, where you will turn left eastward and drive on 180 toward Kings Canyon. 8.2 miles after getting onto SR 180 and then 20.4 miles past stop 2, pull right into a large turnout. As we climb higher up the mountain towards Kings Canyon, the topography changes the higher we go. The next stop gives us a magnificent view of an open landscape. This modern-day topography went through a transformation over 5 million years ago. Additional uplift and deepening of the canyons, combined with erosion and deposition processes, helped create the valley you see below. There are drainages that are eroding material off the surrounding mountains. Erosion helped carve out the valley and drown some areas with sediment. Sediment also filled up a canyon that was carved earlier on by stream erosion. Local drainages were not able to drain to the oceans, but drained to a closed depression in the southern San Joaquin Valley. It builds up in the southern valley and starts filling up the basin and backs up into these drainages, which is called drowned topography. As we continue, the road begins to climb more steeply because it ascends one of the west-facing topographic steps. The cross-section of the southern Sierra Nevada is very different compared to the northern Sierra. The northern slopes are very even and extend from the crest westward toward the valley. The southern slopes in the Sierra don't drop off so quickly westward from the crest until further far west. At this location, the big west-facing steps are original in the southern part of the west flank of the range. Geologists believe that erosion has to do with the steep slope rather than faulting, but the subject is still debated today. The Sierra Nevada has helped geologists discover the number of revolutions in the study of the landscape evolution. They call this geomorphology, and this mountain range is one of the best study areas. From stop 3, get back on SR 180 and proceed into Kings Canyon National Park. Stay on the road to Cedar Grove and keep straight after entering the park. 26.1 miles after stop 3, on the right hand corner, carefully pull into the turnout for the Junction View viewpoint. This is the famous Junction View. This is the area where the Middle Fork and South Fork Kings Rivers both join and become visible. This area oversees one of the deepest canyons in the United States. This was carved 3.5 million years ago. You can also see the Spanish Mountain. What makes this canyon impressive is its depth and steepness, which was carved by the work of running water. Rocks and other debris were the cutting tools when the water carried these downstream. Geomorphologists are puzzled on why certain types of rocks, like granite, eroded faster due to fractures and weather erosion. Metamorphic rocks are more resistant to weathering and therefore are left sticking out in the canyon. From stop 4, resume driving eastward toward Boyden Cave and Cedar Grove. This will be 8.7 miles after stop 4, and you will be arriving at Boyden Cave. As we drive through the canyon, we see the very narrow areas of the canyon that are carved in all metamorphic rocks. These include marble and limestone rocks, which are also called cherts. These are rocks that were deposited on the bottom of the sea floor in deep water areas, which were far away from the continent. The recrystallizing of limestone forms marble itself. Marble is found in shallow marine environments and in the largest limestone deposits in the trailing edges of the continents. This is also known as a passive margin. Both the west and east coasts are passive margins. As we continue to drive upstream, we transition from a canyon carved only by moving water to a canyon that was carved by moving water and then modified by further glacial erosion. From stop 5, resume driving eastward on SR 180. This will be 12.5 miles from stop 5. You'll be pulling right into a turnout just short of the bridge over Roaring River. Our final stop takes place near the end of the road of Kings Canyon. The steepness of this area shows how glaciers played a vital role 15,000 years ago. Glaciers once filled up this area. It made the valley more of a U-shaped profile. This area also has evidence of the rocks breaking off the mountain cliffs due to weathering or may have resulted from earthquake activities. You can see the light patches on the cliff sides, which shows where pieces of rock have peeled away. It is light colored because lichen, which is a darker color, has not grown over the fresh patches yet. Some lichen that is found on fallen rocks is used to help geologists determine the age and the frequency of rockfalls. Earlier on the trip through the canyon, there was also a big white patch indicating that rock had peeled away off the canyon. Besides weathering and earthquakes, there are times the weather environments play a part in helping Kings Canyon. Lightning strikes help clear out brush and vegetation in the park. You can call it a form of environmental recycling, and local rangers monitor the fires as they burn out. I hope you enjoyed your trip to Kings Canyon National Park. This place is an area for many tourists to see and understand how geology helps structure this magnificent place.